Good morning, students. Today, we will begin with a new topic, that is mole concept, from chapter number 3, present on page number 40. Students, this is one of the most important topic present in this chapter. So let's begin. Now students, for counting common objects, we use the terms like dozen, pair, or a deck. For example, a pair of gloves means 2 items, a dozen banana means 12 items, and a deck of cards means 52 cards. But students, if we have to count the number of atoms or molecules present in a substance, we cannot use these terms. It will be very difficult for us to count these atoms or molecules present in a substance because these atoms and molecules are very small in size. Even in a small can of aluminium, there can be billions of aluminium atoms which can be present there. Therefore, how can we know or how can we count the number of atoms or molecules present in a substance? For this, we have to learn mole concept. Here is an example. Here is a piece of gold, and just by looking at it, can we calculate the number of atoms which are present, or can we calculate the number of molecules present in a glass of water just by looking at it? You will say that it is practically impossible. We cannot calculate or count the number of atoms or molecules from a substance. But science has an answer to this, and that answer is mole concept. Yes, if we are able to understand about the mole concept, we can be able to calculate the number of particles, that is atoms or molecules, present in any substance. Now, what exactly is mole? There are several definitions of moles. We will be going to learn them one by one. But before that, we will be learning the simple and the basic explanation of the moles. After the completion of the topic, we will go for more complicated and the actual scientific definition of the mole. Right now, we will be focusing on only the simpler explanations or meanings. In simple language, 1 mole of any substance is equal to 6.022 into 10 raised to 23 atoms or molecules or particles of that substance. Let me repeat this once again. 1 mole of any substance means 6.022 into 10 raised to 23 atoms, molecules or particles of that substance. Now this number is quite a huge number. You can see over here, it is quite a huge number. And this means that if any substance, let us say, a substance contains 3 times this number, that means it contains 3 times the 6.022 into 10 raised to 23 particles, then we can say then that substance is equal to 3 moles. Similarly, if a substance contains 8 times this number, that means 8 into 6.022 into 10 raised to 23, we can say then that substance is 8 moles. So once again, I'm repeating that 1 mole of a substance means 6.022 into 10 raised to 23 atoms, molecules or particles of that substance. So now students, if I ask you the question that how many atoms are present in 1 mole of pure gold, you will say that 6.022 into 10 raised to 23 gold atoms, because it is 1 mole of pure gold. Similarly, 1 mole of pure water will contain 6.022 into 10 raised to 23 water molecules. With this students, we understood the relation between the moles of a substance and the particles of a substance. Now students, the number 6.022 into 10 raised to 23, this number is also known as Avogadro's number, in the honor of a scientist, Lorenzo Romano Amedeo Carlo Avogadro, which means Avogadro's number means 6.022 into 10 raised to 23. And this number is used to represent quantities similar to dozen and pair. We know that 1 dozen means 12, 1 pair means 2. Similarly, Avogadro's number means 6.022 into 10 raised to 23. And it is written as or represented as N0 or Na. That means N0 or Na means Avogadro's number, which is 6.022 into 10 raised to 23. In simple words, 1 mole of a substance is equal to Avogadro's number of the particles of that substance. With this, students, we have established a relation between mole and the particles of that substance, which is 1 mole of a substance is always equal to 6.022 into 10 raised to 23 particles of that substance. Now, using this relationship, we will try to solve certain numerical problems. First of all, the first question is, calculate the number of moles for 12.044 into 10 raised to 23 number of helium atoms. Now, students, in this case, we are provided with number of atoms and we have to find number of moles. That means, in this case, we will be using the relationship between moles and atoms. Now, we can solve this numerical either by direct method, that is the unitary method, or by using a formula. Now, first of all, by unitary method. In this case, we will first of all find the number of moles for one helium atom, and then we will multiply it with 12.044 into 10 raised to 23 to find the number of total helium atoms. So, we know that 1 mole of a substance is always equal to 6.022 into 10 raised to 23 particles of that substance. In case of helium, we can say that 6.022 into 10 raised to 23 number of helium atoms will be equal to 1 mole of helium. Now, for 12.044 into 10 raised to 23 helium atoms, we first have to find the number of moles for 1 helium atom, which comes out to be equal to 1 upon 6.022 into 10 raised to 23. Therefore, for 12.044 into 10 raised to 23 helium atoms, we will multiply this term with 12 into 10 raised to 23 and we will be getting the number of moles that is equal to 2 moles. So, this is the unitary method in which we will first of all find the number of moles for 1 helium atom and then we will multiply it with the number of atoms that we have to, for which we have to find the number of moles. In this way, we will be getting the total number of moles for all the atoms. Now, students, we can also solve this question using a formula, that is N is equal to capital N by N0. But first of all, let's understand that what does these symbols represent. Now, students, small n represents number of moles, capital N represents number of particles, which can be atoms, molecules or ions, and N0 represents Avogadro's number, that is equal to 6.022 into 10 raised to 23. And the formula for solving, or we can say the formula for relating moles with particles is small n is equal to capital N by N0. Now, how we have derived this formula? First of all, let's understand that. Once again, come back to the unitary method. Here, we were trying to find the number of moles. And final portion, that is this portion of your numerical, we come to know that number of moles is equal to 12.044 into 10 raised to 23 divided by 6.022 into 10 raised to 23. Now, what is this 12.044 into 10 raised to 23? This is the number of particles that were given to us. That means we can write down that number of moles is equal to number of particles divided by 6.022 into 10 raised to 23, which is your Avogadro's number. So, in short, we can say number of moles can be given by N, that is number of particles divided by Avogadro's number. So in this way, we have derived this formula, that is the relation between number of moles and number of particles. So once again, using this formula to solve this question, here in this case, we are given capital N, that is 12.044 into 10 raised to 23, and we have to find small n. Now using the relation small n is equal to capital N upon N naught, and substituting the values, capital N is equal to 12.044 into 10 raised to 23, and N naught is Avogadro's, that is 6.022 into 10 raised to 23. Answer is 2 moles. Now it is up to you that whether you can, that if you want to solve this question using unitary method or using this formula. Let's discuss another problem. But before that, let's understand now that the relation between mole and substance is equal to this, and we can also establish a formula, that is small n is equal to capital N upon N naught, to relate moles and particles. Another problem, calculate the number of particles in 0.1 mole of carbon atoms. So first of all, unitary method. We know that for 1 mole of carbon atoms, number of particles or number of atoms in this case will be equal to 6.022 into 10 raised to 23. Therefore, for 0.1 mole of carbon atoms, it will be equal to 6.022 into 10 raised to 23 into 0.1. And the answer comes out to be 6.022 into 10 raised to 22. Or we can also solve this question using the formula, that is small n is equal to capital N upon N naught. In this case, number of moles is already given, and Avogadro's number we already know, and we have to find capital N, that is number of carbon atoms. Now students, one thing that you should always do is that always write the formula of the substance at the top, because the formula exactly tells us about that whether the particles are atoms or molecules. In this case, the formula is C. That means in this case, the smallest particle will be your atoms. So we have to find the number of carbon atoms, and using this formula, answer comes out to be equal to again 6.022 into 10 raised to 22. So this is how we solve the numericals which establish the relation between moles and number of particles.